Getting a perfectly melted s'more usually means lighting a campfire. Today, we are going to do it without a single spark or electricity. Instead, we are going to build a working oven using an ordinary pizza box and the power of the sun. It is an easy afternoon project to build together, and it introduces renewable energy engineering to keep your kids' minds sharp over the summer break. Here are the exact materials you will need to get started: a clean pizza box, a roll of aluminum foil, plastic wrap, a sheet of black construction paper, clear tape, a utility knife, and your s'mores ingredients. We are going to take these everyday household items and arrange them to concentrate solar radiation into a functional cooking tool. Let's start building. Step 1 is preparing the lid. Draw a square on the top of your pizza box, leaving about a 1-inch border around the edges. Then cut along 3 of those lines so the cardboard folds upward, creating a standing flap. Because this requires a utility knife, an adult needs to handle the cutting while the child observes. Next, take a sheet of aluminum foil, fold over the inward-facing side of that newly cut flap, and tape it securely into place. Check your foil and make sure the shiniest side is facing outward toward the sun. This animated diagram shows exactly what that foil is doing. It acts as a mirror. It catches the incoming UV light from the sun and bounces it sharply downward into the open cavity of the box. Engineering that precise redirection of light is the foundational requirement for making this oven work. Now, open the entire pizza box and tape your sheet of black construction paper flat against the inside bottom. This diagram illustrates a process called absorption. When those redirected light waves hit a dark surface, the material captures them and converts them into heat. With your base installed, place your graham cracker, chocolate, and marshmallow directly on top of that black paper. Make sure you leave the top graham cracker off during cooking. The marshmallow needs direct light exposure to soften. By catching all that incoming light, the black paper acts as the active heating element of your oven, turning light into concentrated cooking energy. Close the main lid of the pizza box, making sure your foil-wrapped flap remains standing upright. Take clear plastic wrap, stretch it tightly across the window, tape it to the cardboard. Perfectly seal every single edge, leaving 0 gaps for air. This diagram shows the greenhouse effect. Heat waves radiate up, bounce off the plastic wrap, and deflect downward, trapped inside the space. If your tape fails, heat immediately channels out through the gap, leaving your food cold. That strict airtight seal is the single mechanical variable that pushes the internal temperature high enough to cook. Take your sealed oven outside and place it in direct, unshaded sunlight. Turn the entire unit so it faces the sun. Tape a stick or a ruler to the back of the flap. This allows you to prop it at the exact optimal angle to catch the most light. Remember to stay safe. Do not look directly at the sun, and avoid staring into the bright reflection off the foil panel. Now you wait. Over the next 30 to 45 minutes, thermal energy builds inside the box and slowly softens the ingredients. Once everything is melted, break the plastic seal, press your top graham cracker onto the marshmallow, and taste what you've made. You have successfully harnessed renewable energy to alter the physical state of your food. For more family projects like building an egg parachute or a homemade barometer, check out the Discovery Ranger's Guide linked in the description below.